A charged particle may move in electric field or in magnetic field. So it will experience a force whether it is moving in electric field or magnetic field. First let us see about charged particle moving in uniform electrical field. So uniform electrical field we can denote like this. So what is the force? A force in an electric field, Coulombic force is given by both the charges, sum of the charge by 4 pi epsilon naught. See, we can write like this. Source charge and test charge 4 pi and the distance between the charge. Force electric field is equal to force experienced per test charge. This is the test charge. So which is equal to Q by 4 pi epsilon naught r square. This we have already studied in Coulomb's law. Or we can say force is equal to the force on the test charge, Coulombic force in vector form we can write like this. So this is the force given by the electric field. Now the electric field is from here to here because from positive charge to negative charge. This is the way how the electric force, Coulombic force, it will be upward direction, in the upward direction. Now let us consider a particle that is positive, a particle of positive charge. Generally, particle Q is equal to charge, Q is equal to charge, M is equal to its mass of charge. Mass of charge, Q is equal to mass of, and moving with a velocity v. Moving with a velocity v in the electric field. This is charge, positive charge. V is equal to velocity of the particle. Velocity of the particle. So if the charge plus Q, we consider positive charge always, negative charge means it will be in the opposite. We will discuss it later. A charged particle of mass m moving with a velocity v along OX, we call it as OX, along OX. This is O and X, OX. In this way it is moving. When it is moving, it will definitely expect, and in the absence of, if there is no electric field, this is absent now. If this is absent now, if there is no electric field, if there is no electric field, if there is no electric field, what will happen? It will, the charged particle will not experience a force. No force on plus Q, hence it will move straight. So no force, if there is no force, this force is equal to 0 now. If it is equal to 0, it will move straight and hit at this point. It will strike at this point, if no force. So see, in the absence of electric field, it will move straight, meet the screen at A. We call it this point as A. So now we apply electric field. This is apply when we apply the electric field. Electric force is this way. This is positive side, and this is negative plate. This plate is plate. So electric field, see, electric field, since it is a force, the force is always, this is a scalar, the force is always in the direction of electric field. Electric field is from positive to negative side, therefore the force due to electric field is upward direction, in this direction. So this will experience a force. So when electric field is introduced along the vertical upward direction, that is along y-axis, we can take the reference. This is x-axis, this is y-axis. Along y-axis, along y-axis. Due to electric field, the charged particle will experience a force is equal to F is equal to Q into E. In which direction? In the upward direction. Since the particle is moving this way, force is in this way, it will have experienced a force in the upward direction. And hence, because of this force, electric body is moving this way, the force is acting, F electrical is acting this way, and this is moving this way, positive charge, it is moving, it will experience a upward deflection along the direction of the electric field. So when it is moving, it will change its path. It will not move straight, it will move slowly, and it will deflect upward slowly, and after leaving this electric field, this area, it will move straight and hit at this point. This is straight line, because here up to here only deviation, from here it will move straight, because there is no effect of electric field. So that means the upward direction, the particle will be deflected along the direction of electric field, and once it is deflected, acceleration is produced in the charged particle. Acceleration produced in the particle. Acceleration. What is acceleration? We have already defined acceleration is equal to a vector, force vector divided by scalar mass, and force is equal to Q into E divided by M. This is the acceleration. So we can write the acceleration in magnitude is equal to Q into E divided by M. This is in vector form. This is Q is a scalar, M is a scalar. Acceleration, and acceleration also will be along this direction. So the particle will move along this O. We see O dash. This will be the direction of the particle, and from here it will move straight. Right? So acceleration is equal to the magnitude of acceleration. Already we have written magnitude of the acceleration. Now let us see, x is the length of the electric field. Now see, the x is the length of the electric field. X is the length of the electric field. So now you see, x is length of electric field. Length of the electric field, and t is equal to time taken. T is equal to time taken to cross this electric, time taken by the particle to traverse this distance x. Time taken to traverse this distance. It means from here to here it is x, and it takes a time of t to travel through this distance within the electric field. Now what is the y? Y is the distance traveled by the particle along y-axis, this distance. You can say this is the distance y, because it has got two-dimensional motion. So we have to see the motion in the x direction and motion in the y direction. And this is the path. It means this is the distance travel in x-axis, and this is the travel in y-axis. Now we can say y is equal to distance traveled by whom? Traversed. It is right word to say is traversed. Traversed by particle in the same time t, because it is from here to here, it reaches in t second. It means it crosses x distance in the same t second, and it moves y distance in the horizontal distance also. So now we must have seen in the projectile motion. In the projectile motion, what it says, we have to consider the motion in both the direction, this way also, projectile will move like this much of x distance, this much of y distance in the same time, because it is reaching this point in t time. It means in t time it is reaching x distance, and the same time it is reaching y. So this is the particle is moving this way, this is the x distance, this is the y distance. Now we have to consider motion in horizontal as well as motion in vertical direction. Equation of motion. We must have studied in +1. Equation of motion, 3 equations. Now we will use this S is equal to ut plus half a t square. With this is the distance traveled, this is initial velocity, and this is the time taken. This is acceleration of the body, and the same time squared. So in the horizontal, first we will see in the horizontal direction. In horizontal direction. In horizontal means in this way motion. Horizontal motion, S is equal to distance travel is equal to x distance it moves. From here to here it moves x distance it moves, and initial velocity is equal to v, because it is entering with the initially it is entering the electric field with a velocity v, and acceleration is equal to 0. Why acceleration is equal to 0? Because there is a force is acting in this direction due to electric field. There is no force acting. See, what is acceleration? Acceleration of force by mass. When there is no force, that is equal to 0 by m. So acceleration 0 in the horizontal direction. Acceleration has to be 0 in the horizontal direction. That is why acceleration is equal to 0. So substituting in this equation, S is equal to x, and u is equal to v, and t is equal to t plus half into 0 into t square is equal to vt, or time taken is equal to x by time taken by the particle to reach this point. At the same time it is traveling x direction. So t is equal to x by v. This is the time taken. The particle. So now we have to see in the horizontal direction we have seen. Let us see in the vertical direction. The vertical direction, because we got two types of motion. Body is moving in the vertical direction, horizontal direction. This is the combined motion. O dash is the combined motion. In vertical direction. Distance travel, S is equal to y, because it travels a distance of y in the vertical direction. And acceleration, what about the acceleration? This is the equation for acceleration. Because force is acting this way, therefore acceleration is equal to q into e divided by m. This is the acceleration. And what is the initial velocity? Initial velocity is equal to 0, because when it is entering, it is moving in the x direction, there is no motion. When it is entering initial point, there is no velocity in the vertical direction. Here only it has got vertical component, horizontal component, and vertical component. Here the initial velocity in the vertical direction is 0, because it is entering along x-axis. Further it goes in a curved path. So v is equal to 0. So velocity is equal to, initial velocity is equal to 0, and time S is equal to ut plus half at square. So we can write, substituting in this equation, y is equal to 0 into t plus half into a t square is equal to half a t square. This is the distance travel in the y direction. Now, so since y is equal to half into a into t square, as it is we have found out the value for a. What is the value of acceleration? Half into acceleration. Acceleration is equal to QE by m into t. T is equal to x by v, that is x by v whole square, t square. So this is the expression for the displacement in the vertical direction. Now you can say x square. What is this? Y is equal to QE x square by 2m. We can write this equation, or we can write x square is equal to, what is the value of x square? X square is equal to 2m v square by q into e into y. This is the equation. This seems like a equation of parabola. What is the equation of parabola? Parabola. If the medical people, the PMT people does not know, I will give x square is equal to some constant into y. This is x square, or y square is equal to some constant x. Here the second degree, here first degree. So here this we can write x square is equal to this, we can consider as this 4a constant into y, or this seems constant into y. This seems the same equation, x square is equal to second degree equation, first degree equation. What it says? It says x square is a constant, where because a constant and multiplied by y. A constant multiplied by y, which is the equation of a parabola. This is the equation of a parabola. So we can come to a charged particle moving in perpendicular to the uniform electric field. How a charged particle is moving perpendicular? See, charged particle is, how the charged particle is moving? This is the way the charged particle is moving. The electric field is in this direction and electric force in this direction. A charged particle moving with velocity v perpendicular to the electric field. A charged particle moving perpendicular, a charged particle moving perpendicular to an electric field, perpendicular to move, it will follow the path, because from here it will follow, this is the path of a parabola, that is O dash. A charged particle moving in electric field will follow a parabolic path, will follow a parabolic path. This we have to remember, because this result will come handy.